Ladies and gentlemen, I am honored to have the opportunity to participate in this meeting. I shall take about 10 minutes of your time.
First of all, I want to introduce myself. I am from Chongqing Telecommunication Polytechnic College in Chongqing, China. The title of my academic presentation is Low-Frequency Noise Characteristic Extraction Method of Electronic Components. Based on data mining. I have divided my presentation into 4 main parts.
Low-frequency electrical noise of electronic devices is the manifestation of micro-motion of electronic carrier. Its accurate measurement can provide the basis for noise characteristics, generation mechanism, and analysis application.
The connotation of noise research has been gradually expanded, and the extraction and detection of noise have also begun to receive attention. The internal noise of electronic components, especially the low-frequency noise, is very sensitive to the difference of bystanders or the defects caused by different materials, structures, and processes of hardware components. Therefore, the low-frequency noise of electronic components can also be applied to the study of device quality and reliability characterization.
On the one hand, the deep understanding and explanation of the essential laws of physical phenomena in the theoretical study of noise is the basis of noise testing, analysis, and application research. On the other hand, the study of noise testing and analysis is the verification and supplement of theoretical research, and also the power of noise extraction and testing technology progress and application transformation. However, the accuracy of traditional feature extraction methods is relatively low. For this reason, this paper proposes a method of low-frequency noise feature extraction of electronic components based on data mining. And the experimental results show that this method can effectively improve the accuracy of low-frequency noise characteristics of electronic components. The specific implementation process is as follows. The method teaches based on data mining to extract low-frequency noise features of electronic components. Data mining is carried out first. Based on this, the noise modulation model of electronic components is established. Use of autoregressive model to extract the deterministic components and obtain the autoregressive model of low-frequency noise. Then, by linear transformation of the autocorrelation function of low-frequency noise, the weight coefficient of linear prediction can be obtained. Combined with filtering, the low-frequency noise feature extraction method of electronic components is optimized. The extraction method of low-frequency noise characteristics of electronic components based on data mining, firstly, establish the noise modulation model of electronic components. The autoregressive model is used to extract the deterministic components. The weight coefficient of linear prediction can be obtained by linear transformation of the low-frequency noise autocorrelation function. The weight coefficient can be solved using Ewald-Walker equations, and the noise modulation model of electronic components is obtained.
Secondly, according to the characteristics of noise modulation of electronic components, the frequency of carrier noise is much greater than that of modulation noise, So the first wavelet packet decomposition frequency band is not included in noise demodulation. The energy coefficient of the noise decomposition frequency band can be expressed by the proportion of the energy of each frequency band in the total energy.
According to the definition of the spectral correlation density function, it can be known that the spectral correlation density function of signal represents the correlation of its spectrum on two different frequency components, and the weaker the correlation, the more characteristic the low-frequency noise performance at the cycle frequency. Thirdly, in order to simplify the extraction process, assuming that the low-frequency noise of electronic components is dominated by white noise. According to the linear prediction, the deterministic signal composition of the signal can be obtained, and then the residual signal formula composed of the low-frequency noise modulation signal component and the noise signal can be obtained as follows. Therefore, linear prediction based on AR model is an effective signal pre-widening tool.
The choice of modulation frequency band has an important influence on the demodulation effect of the final algorithm. When the carrier frequency band is modulated, the modulation frequency band is mostly the frequency band with higher energy. In this study, the modulation noise energy is used as the selected basic index. By synergizing the low frequency noise and intensity of electronic components, a simple model that can produce stochastic resonance is obtained.
Based on the calculation result of the signal-to-noise ratio, several low-frequency noise components are removed to ensure that the remaining low-frequency noise performance is significant, 23, which is equivalent to filtering by a high-pass filter. The filter bank is completely adaptive. Retain the significant performance of low-frequency noise and transfer high-frequency energy to low-frequency. Calculate the center frequency of the MEL filter, select the sampling rate, the upper and lower limit frequency of the filter, and unfold it in the form of a grade, that is, the low-frequency noise feature point of the electronic component is obtained. Now let's take a look at the experimental data of this method.
The low-frequency noise performance of electronic components is selected for reconstruction, and the result is shown in picture.
The analysis of the experimental data on this table shows that the accuracy of the literature 5 method reaches 0.645, and the literature 6 method is 0.781, while the accuracy of this method is up to 0.964. It is seen that this method effectively solves the problem of low-frequency noise performance extraction of electronic components, effectively avoids external interference, effectively improves the accuracy, and significantly outperforms the other two extraction methods. Through the experimental data analysis, I got these conclusions. By introducing data mining methods, the analysis of low-frequency noise performance can be effectively improved, and the improved method is effectively improved by combining modulation and filtering. The effectiveness of extraction and the significant increase in extraction accuracy have certain advantages. It's the end, thanks.